All right. I have uh what's it called? Um the video starting. So this is good. And I can share my screen too, so you're yeah. Oh, host has disabled screen sharing. Yep, take your time. Perfect. Okay. Share. All right. Can you see everything? Okay, perfect. All right. I guess I'll start off like with your prompt: design a video recommendation system for Facebook. Okay. Okay, sounds great. So for this video recommendation system, can I assume that we will be interacting with some like external video storage or API internally, like with Facebook? Hmm. Okay, internal, and let me make this smaller because I know this text takes up a lot of the space. Okay, internal storage and video API callback. Okay, so for this, I probably want to know is this like what's the scalability of this program you want me to design? And the reason I ask that is this going to be like a new feature? Like, are we imagining this as like Facebook 2009, or we're just scaling up for to a couple tens of thousands, maybe a million consumers, or are we doing like current era Facebook with their current volume of people? Okay. Okay. And just as a rough estimate, I'm gonna assume like 1 billion potential um, uh, users. So 1 billion potential users, and then also I think a good metric to at least discuss is the average length of the video. So I know compared to something like Netflix or YouTube, they have longer form content. At least my general experience with Facebook video, it's typically it has a little bit more virality to it. So I mean like that, it's like shorter form content with the potential for longer form content. So um, I'm gonna just make an assumption that the average video is maybe 3 minutes. Would that be okay? Okay, so it's a video, and then if you compare this like and I don't want to make too much comparisons because I know it's its own thing, but uh, if you could kind of compare this to Netflix, Netflix has like a smaller library of overall video content because they license it out. The thing when you consider like these big scalable systems like Facebook and Google is since it's a lot of user produced content, there's going to be a higher volume. So I'm assuming that for our video streaming, we want because of this high volume of uploading and then also viewing, we want very low latency. Mhm. Okay. Okay. Don't have to care about the streaming. Okay, that's really great to know. So I don't have to jump into the weeds there. Now that I can focus on this recommendation system, um, uh, when I'm thinking about like a great social network like YouTube or Facebook. There's a lot of users there, so I think it's a gold mine of user metadata that we can utilize to kind of fine tune this recommendation system for our clients. So things like their geolocation, other metadata tags like preferences, language, geolocation. So I'm just going to put a little note, metadata such as geolocation, friends, list, watch time metrics, and engagement. I know engagement is very important as well. Actually, when I think about like these mobile-focused video delivery systems, actually like how much you comment, how much you really improves the overall recommendation system. So I'm going to probably be using a lot of that specific metadata to improve the overall algorithm. So metrics metadata. Okay. And then just because I think this might help for a specific user, is there a safe average amount of friends I can assume, like 500 friends per the average user? 50. Okay, 50 friends. And the reason I ask is because you like one component of the recommendation system or the underlying base recommendation algorithm could be I think it's collaborative recommendations. So what that specific is, like let's say you have four friends, right? You like two movies or like two videos and don't like two others based on this engagement metrics. And then you have like the four other friends, and whoever you're closest to when they watch a new video, that would probably be recommended to you next on your queue. Yep, yep. So, and then another, so besides collaborative filtering, I think how I like to kind of define this, and let me know if I'm straying too far here, is like a hybrid approach. So not only the collaborative filtering, but that metadata as well, because it provides like the best of both worlds for this recommendation. And the reason I say that is not only can you kind of do this, what's the right word? Yeah, collaborative filtering, but you can also do um, that same type of like metadata on the actual video content. So maybe it's a lot of like sports related content, um, and and then like if you combine that with your friends, then that's just a really personalized feed. So collaborative plus metadata approach. And let's see. So you have your friends, which is the collaborative filtering. You have the metadata approach, like that, which includes tags. Okay, so for this system, what is our underlying driving KPI? Like, what's our key performance indicator? Are we like caring more about like retaining the user's attention for the most amount of time, or is it more about like delivering the most unique, pleasant experience? Okay, users on. Mm-hmm. Okay, okay, that's great to know because I I think that's like typically like the key metric a lot of these recommendation systems have, at least for video consumption, is the stickiness. If you compare to something like TikTok, I know like my sister and like her friends, they're like glued to the phone, but that's because the recommendation algorithm is so good and fine tuned. So I have one more question on this recommendation system, like for goals. Um, Oh, actually, a couple. I assume that we want to be able to filter out content that goes against our community guidelines. Would that be a safe assumption? So, like, Okay, perfect. And then oh, yeah, okay, cool. So this is the Wild Wild West. This is Mastodon. Free speech is the other key metric. I understand. Okay, okay, and then the other one, yeah, the other one I had is typically with recommendation systems, you can also get so fine tuned if you kind of think about it in a machine learning model. Like it's you're overfit for your overall model. And sometimes it's good to include content that might not be in your user's preference, but expands their yeah. Okay. Okay. And the only reason I was thinking about that is because it adds to overall stickiness. There, and it makes our algorithm not seem stale. But okay, this I think this is good. Uh, yeah. So for the metadata, let's see. We have our 50 friends, got 1 billion users. Um, so, okay. And then for if each person has on average 50 friends, I think we have 50 billion edges within our like a little graph. So 50 billion edges. So that's like potential connections. Um, okay, metadata. Okay, so I'm going to go a little bit into data model design because I really want to see like what would be the appropriate metadata for us to keep based on the KPIs we were talking about. So let me add another text box right here. Okay. Oh, and before I go on this data model design, I just thought of one non-functional requirement I think would overall improve our system. So I'm just going to briefly mention it, and if we have enough time at the end, I'll dig a little bit deeper. But it's actual logging and monitoring of our metrics. So if like watch time or engagement metrics are going down, then we can like tweak our underlying algorithm. So may discuss later. Discuss later. Okay. So for our metadata, the thing I like about usually like this metadata, especially if we're in at least in this recommendation system, we don't have to necessarily keep track of user information because that's probably another internal service. Unless you want me to design that, okay, I can safely assume that is we can use a NoSQL data store, and then the reason that's good is because it's like very easy to access, and then like from that data, we can access other parts of information. But let me just do a little rough example of what our data model look like. So I think we'd have user ID. So that would just be probably something like a 8 or 12 like varchar. No, actually it would probably be like 8, especially if we use like something like a SHA algorithm or something. So with that, and I think the most important stuff is again our friend data and then also our actual like watch time metrics. So actually this can probably be pretty high level. So friend data ID. And maybe I jumped the gun a little bit too much on this NoSQL thing, because now what I'm kind of thinking about is um, I have this high level metadata, right? So I have user ID, probably like the friend uh, data, and that can kind of query database. And I also have like the watch time metadata, and that can query its own stuff as well. Metadata ID, friend data ID. Okay, and yes. Mm-hmm. Okay. Okay, perfect. Okay. So, like just a quick high level, the high level components. Okay, cool, cool. So, I think high level components we're going to have something, and I'll just make these very simple shapes. Okay. So you can imagine like these circles as like data stores. Um, so we probably have different data stores, and I think the most important part is going to be like this middle application layer, because it's going to ingest all of this data and then return our recommendations to the client. So because what it can do is like for this friend data ID, this friend data, like metadata and then watch metadata, it can basically utilize both data stores, and then there's like different subcomponents in that application layer. So we have like the ingestion, then we have probably like some type of ranking based on this portion right here, the collaborative filtering and metadata. And I know we didn't talk about, we like driven away from it, but in the future, you could probably add something like removing like content we don't want to introduce to users, and then maybe add ads as well. I know that's outside the scope, but I'll quickly add the application layer. All right. Okay, so that'll be our application layer. Then we'll finally have our client on the left side. Okay. Client. Okay. I think from here, scribble, right. So from here, when a user makes a request, like so they're pulling from this recommendation system, the only major portion of information that they're sending is, the only major portion of information that they're sending is their user ID, and that can be collected to the different data stores. So I'll put that right here. Oops. Okay. This is our app layer. Okay. This right here will be our like watch time metadata. Yeah. Yep. Mm-hmm. Okay. Yep. Yeah. Okay. And I'm sorry for not clearing this up. So my interpretation is a client goes to their normal like video news feed, right? And like once they're on that page, they send a request out to this recommendation system. The recommendation system like queries all the data on the data stores, and like in the app layer, then it just reprioritizes what videos to show, and then that like feed is shown to the user in a queue. Mm-hmm. Okay. Okay. Yeah, it's basically that little like timer thing, like hey, 15 seconds, you're or like mm-hmm. Yeah. Okay. Perfect. Yeah. So like you're saying, like on the right side, hey, here's the next video that's gonna play, and then like here's like similar videos, right? Okay, cool. Okay. Okay, that's good to know. I think from that understanding, then uh, you actually have um, a lot of leeway, just because whatever the first video the user selects, that could be something completely new. So that's a chance for our recommendation system to um, show something unique besides their like common habits and watch patterns. So from there, let's see, they're watching a video, right? So, oops. Okay, what's happening? Okay, they're watching a video. Okay. So they're watching a video. There's probably some time data that we're using. Like, hey, we're no, no, no. This would probably be generated as the video is loaded too. Um, okay. So for this, okay, I think there's an additional layer. So what I mean by that is let's select. Okay. Oops. Okay. Okay, I guess it's just all there. Okay. Um, what I'm thinking is like when a user first watches the video, we already have something queued based on their metadata, and then probably a little bit of the trending videos as well. And that will probably be based on videos their friends has watched, and then the general community as well. Um, yeah. So what I'm trying to do here is okay. I got it. Boom. Okay. All right. Yeah, yeah. I gotta move the individual letters. Okay. So basically, like this top layer, like a user requested video, right? Oh my God. Okay. One second. I'm still getting used to this platform. Okay. So like right here is their first. Yeah. 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 This is shit, dude. No, no, no. Okay, so that's video one, right? I think when the user sends a request, like we can just queue up like recommendations, like five videos, something like really like easy that we can like probably cache, like like specific to that user, and then like if they watch like more videos, let's say they get to video three, like we can like send a query for more videos. So it's almost like the results are paginated. Um, mhm, mhm. Hmm. Okay, so then leisure videos with kittens. Okay, so that's it. I think that's a good point. So we probably we want um, our first query of videos to have a bigger percentage of that recommendation. So if it's in the news, then they'll have like news related topics. And then you're like saying in the example, like, hey, they have a long hard day at work. Now it's more like fun videos, and then that could change as well. So let's say they're in like video two and they're done with the cats, and now they want to they search in the search bar something like hardware, like do-it-yourself projects, then those videos would show more of that do-it-yourself type of videos, correct? In this system. Yeah. So uh, like on YouTube, and I'm pretty sure it's similar on Facebook too. You can search for videos with specific titles, specific keywords. Yeah. So um, let's say that the at first the user watches the cat videos, right? So our recommendation system is going to probably do something pet related, cat related, something that a lot of other of their friends are looking at. But let's say they eventually change to, hey, I'm trying to build a table, right? So they use the search bar and look for how to build a table videos. Then yeah, yeah, I'm asking, is that something that is in our system? Because I think that could change the immediate recommendations to the client. Mm-hmm. Mm-hmm. Yeah. Okay. Yeah. Yeah. Okay. I definitely understand to have like the queue constantly um, fill like full, like where we can recommend other videos to the user. I guess what I'm asking is if they do eventually do that manual search, right? Like, is that gonna completely um, change the queue in the system? Is that what you want me to move towards, or just focus on? Okay, yeah, yeah. So all I mean by the queue is like how you mentioned, if you were to watch YouTube, if you watch cat videos, most likely you're going to be recommended something pet or cat related, right? Or if you watch something about like finances on YouTube, you're gonna like get finance YouTubers, right? Or on Facebook, if you're looking at video games, you're gonna get other video game streaming content. And I guess what I'm asking is how big of those recommendations do we want to send the customer? Is it just prepping up the next video, or is it kind of like the YouTube? Yeah. Mm-hmm. Yeah. Mm-hmm. Okay. Okay, I think I understand a little bit more clearly. So what I'm thinking, we could take this is a user watching one video, right? And they definitely have one specific video ID queued up for autoplay, right? And then the rest of the 19 videos, you have like just kind of like static data. So maybe like a generated thumbnail, title, and then that specific video ID. But probably none of the other data, correct? So I think what's going to happen in the system is, let's say you are finishing your video, correct? And you have that next video ID on play. It plays or it changes to the next video. So that video is retrieved from our backend data stores. Um, then our recommendation system is going, yeah, 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 yeah. Okay, gotcha. Okay. Then I think it's a simple thing of on this app layer right here, um, depending on the video, just having or providing a list of the video ID with the most relevant like score, so ranking score, um, and that gets put on the queue, and then the rest of the 19, I'm just gonna like as assumption say we're gonna like show those 20 video on the side, but the actual next video ID enqueued is the one with like let's say 99% relevance to the video being watched, and that score is generated on this app layer highlighted right here. So in yep, yeah, and how is that calculated? So we calculate that metric based on that just hybrid approach. So the collaborative filtering and the metadata approach. So how does that work? So let me just put recommendation up here so it's a little bit more clear. Recommendation app layer. Oh, okay. Don't know why that disappeared. Okay, we're just gonna go simple, easy text box. Recommendation app layer. Okay. So with this, okay, so our metadata, off the top of my head, I'm thinking friends, geolocation, probably within that location, trending topics, and like overall like watch time. So let's do another shape right here. Okay. Okay, so friend watch similarity, watch video similarity, and basically based on this like user ID, we query the friends data store. Yeah. Oh, okay, yeah. I'm sorry, I wasn't clear. I don't mean this as like a front end. I mean like the actual user watching the video. Yeah, yeah, this one right here. Yep. So let me put that to be clear. Front end. Okay. And yeah, so this is the video they're watching currently. So maybe I can do a certain color. No. Okay. Yeah, so this right here is their current video watching, and then we'll just say that this box right here is those 19 other videos with the metadata like in the thumbnail. So 19 thumbnail. Okay, I'm not gonna try that, but yeah, yeah, and okay, so I I I I I'm gonna quickly kind of just include so friends metadata. Okay, and then let's copy this. So we'll just have a couple. So user metadata or preferences. Okay. Then I think we should also, since like Facebook's a global company, I would include something like checking videos from other geolocations, because I'm sure like you've seen like a hit video like a couple years ago, that South Korean rapper Psy, like that's something that if it got big enough, we would want that to share that with the metadata in our US location. So like this is only a small portion of the system, but like for each geolocation, we're going to be like including kind of like a similar structure, and like each system, like on this backend data store, would be sending out from this data store right here. So we'll just say like trending topics / video. So this is also metadata store. So we would just be using like a pub subsystem. So if it reached a certain threshold, like, hey, these are the top 3 most popular videos for this region, send it to another region, show it to a couple of users, and if it gains enough of that stickiness with the engagement, which we would know from like this specific region data store, then show it to more and more. So you would show it more based on those engagement metrics. Now, on actually queuing up the video, I know we said that we're going to use the video ID, so we'll probably be using like a general video blob store here. So like this is internal, right? So we're not doing any of the streaming, but like we're getting like the necessary like data to send to the overall front end. Oh no, actually, you told me not to worry about that, so I won't. But essentially, that's how it would work. Like we already have, yeah, yeah, yeah. Mm, okay. Inputs and outputs. Okay. So for inputs, I think what's happening is the user has a video they're watching, and from that video, that gets sent over to the backend, right? So all that 2 inputs: the user metadata and the video data. Um, yeah. So video data. So what I mean by that is data. There were historical like watch history, like so watch time on certain videos and topics, tags for like videos they're watching, and then like what they're currently watching. So let's say they're currently watching a video and they only watch it for 3 seconds and skip to the next video. That's information that would be relevant to restructuring the recommendations. Yeah. Okay. Okay. User ID and video ID. Okay. And then outputs are basically those 20 video IDs from the recommendation system, and further data for that the one with the highest score. So I guess if overall it'd be a list of video IDs, probably with a score, priority score. And that score comes from our collaborative filtering and metadata calculation. Yeah. Okay. Okay. Yeah. So a high level, basically, all this information. So friends metadata gets sent the user ID, right? Your friends metadata comes back to the recommendation system. To the trending topics, we send it the video ID. So there's probably some counter on like most watched videos in like a given region. So actually, I wouldn't say like user ID, but you could probably add some of the user metadata based on that ID too, to query some interesting information. Yeah, so like I'm not saying like the whole thing, but it'd probably be useful to at least along with that user ID and that video ID like include like the geolocation. Hey, this is popular in New York, and um, with that counter, like you have a little a bit of more granularity. So maybe first to start like a trending video starts off like in New York City, then expands to New York, and then maybe it becomes like a nationwide or global like video. So that's how like some of the user metadata could be useful. Um, yeah, I mean, we don't have to include that. I think the video ID is like fine there. You have like simple counter for right now if we don't want to. Um, okay, keep it simple. Okay, I got it. Sorry about that. Yeah. For this data store right here, user metadata, just you send the user ID, and then it's current like video watching habits. So hey, oh, and video ID. So no wait, user ID. They watched this video ID. They watched it for this much amount of time. This was like the video tag or topic. Okay, yeah, that gets sent back to the recommendation system. I already put friends data. Okay, so let's see. And then here uh, you you have like all this metadata coming back based on those two inputs: user ID, video ID. Um, our application logic just has a way to like combine the information, and then it generates that priority score. Then from here, oh, did I? Okay, I see. Okay, so let's say that's like our list, right? And then we have like video ID, so vid ID 123, right? And then a PR, oh sorry, a PS of let's say like 96%, right? That's the highest one. The lowest one for this probably be like something like 89, right? And then this specific oops, okay, this specific top user ID, um, we would put we would interact with our internal video store and just say, hey, when the video metadata from the video ID reaches like this amount of like time, start queuing up the load for the next video, right? And then the rest of the 19 videos, it's a simple like, hey, get like a small thumbnail, the title of the video, and maybe like view count. Mm-hmm. Yep. Yep. Okay. Good. Gotcha. Okay. So, yeah. So this video IDs and priority score gets sent to the front end, and yeah, that top result. So index zero recommendation video gets put on the top, and then the rest 19 are at the other part of the list. And yeah, that information just gets recommended to the user. So that'd be at high level. Mm-hmm. Okay, yeah. Oops. Okay, video ID 2. So that's our input. And then this, and so this is our output, but for the user watching is like current video ID. ID. Okay, so now on a finer detail, what is happening with those that list of 20 video IDs and priority scores is and let me know if I'm going too far off base, but like I mentioned earlier, I I think you can. Okay, let's put this circle right here. So like you have video details right here, right? Uh, Video details. So I think you have like a service in between this video details data store and it queries like your current like queue, right? So mhm, yep. Hmm. Okay. So mhm, mhm, okay. Um, yeah, with the user ID and video ID, um, it's okay. Okay, so maybe I'm misunderstanding, but I thought that's what I was detailing with this back end portion right here. Like it, yeah. Okay. Yeah. In depth. Okay. Okay. Mhm. Okay. Um, okay. Yeah. Yeah. With the finer detail, like when you have this, I think that's what I may. Yeah. Go ahead. Okay. Yeah. Sounds good. Thanks for clarification. Uh, so yeah. Uh, the user watching a video on the front end, they send a video ID and a user ID, right? That gets forwarded to our recommendation service, and then it points the appropriate like IDs to metadata stores, right? So the first one being the friends. So like we're talking about the 50 friends, we want to look at our like friends like similar video history, maybe like a quick query, and like we're talking about here. Maybe this will help visualize it. Um, yeah. Mm. um, when I'm thinking about like the metadata store, I'm just thinking about something as simple as you have the user ID and then a list of like friends IDs, and then from those friends IDs, like you basically like query their specific like recent like videos they watched, and then like from yeah yeah so um mhm. So the underlying like friends watch um, video data that's stored like in like another like in or external internal system. So you would have to query, yeah, you have to query that. But like high level, this is like what we're trying to get. Um, oops, we're just trying to get like a simple like table. So let's just say like A, B, C, and then like U. So like your user ID, UID, and then let's just say you have like 3 videos, right? Oops. And then let's say it's like video 1, which you watched. So you got like a check mark, X, check. Then you have like some other video 2, 3, and like these are your recent videos, right? So you have check, check, and then check, check, then X. Okay, so based on this, your friends, you have. I know this is like rudimentary, but you have like two friends with a common video that you watched. On this one's only one, and then here you have like 3. So based on this friend's metadata portion, this video would have like a pretty high score and get returned from that query to the external friends like watch metadata. And then from yep, and then from trending topics, I think that's just like a like probably something like a simple count, like what videos are being most watched in your region. So maybe you have like 3 top videos, so you have like 970K views on one video, then another one, let's say like 600K, and that gets like sent back. So like all this information is flowing back to, oops, to your application. And then finally for you, similar to this table up here, oops, similar to this table up here, based on your current like watch, like your current video ID and video IDs you've watched in the past, from that table, we actually, I'm wondering with that, we would probably want to do certain, okay, so I think what I'm not explaining now, realizing I'm kind of going more further in detail from this, even though we have like these common videos, right? So like this ranking for friends metadata, these trending topics, and then the user metadata for like historical like viewing preferences. Once we combine that, like how are we finding those videos, and putting that back into the algorithm. So what I mean by that is like you could have watched like a couple like horror movie trailer videos, right? But how are we finding those general topics of videos to return? So yeah, topics. Yeah. Did we run out of time? Okay. Okay. Mm-hmm. And sorry, I didn't mean to interrupt. I'm so now that I'm thinking about it a little bit more, I think an additional thing like we can add to the system is like general category IDs for videos. Um, the reason I say that is because like for the this actual historical viewing data, right? Like there's general tags and topics, right? And like from like those tags and topics, we probably want to pull like the most popular videos from that general topic. So I think kind of like the Netflix category IDs, they have specific IDs, and I think that would fit into our system of like trending topics. A simple count. So like from that recommendation system, I think what you can do is like you have the only thing that I question a little bit is like you could have basically data stores of general category IDs and then video IDs, and then like that gets retrieved. But I'm wondering if that is like introducing unnecessary redundancy like to the system. Like what I mean by that is okay. Let's see. We have boom. Oops. Okay. Yeah. So what I'm thinking, excuse me, is maybe we're using um, an internal like series of databases similar to these trending topics, but just general topics. And then from our recommendations, like we have those category IDs that are like most relevant to the user, and then we're just pulling like the top videos from that category. Mm-hmm. Mm-hmm. What are multiple categories? Yeah, fit multiple categories. Okay. So because a video fits multiple categories, would that rather than just be another portion of the recommendation system? So the reason I'm saying that is because with this hybrid approach, I'm thinking about like percentages. So maybe like our percentage is like 30% like based on Fred like recommendations. So like their historical data, um, maybe 40% on like user metadata, 15% on trending topics, and then 10% based on like the actual like general topics that you also get from user metadata. So yeah. So and then from these data like these metadata stores, um, they're just pulling from some like overall video ID service, getting that metadata and then returning it to the list of video ID and score. Okay. So like bottlenecks I could see is from all these different components. I feel that for that external and internal video ID data store, that's a lot of like this layer right here, these circles. That's a lot of requests to like one specific service. Um, so so what I think would probably be best is, and I won't keep it simple because I'm not designing that service. I think that service is already designed. Um, but Yeah, yeah, yeah. And like then those are just like retrieving like video IDs to return to this recommendation system. Now, yeah, I'm just trying to see because there's going to be a lot of um, clients sending in their user ID and video ID. Oops, video ID. Yeah. Yeah. I think just like general. Um, so if you're going to send a lot of requests, I think it whatever that like background like video ID data store, you could probably just have like a cache of the most common video IDs, so it doesn't have to make that overall long request, um, and that could all be generated from like the most like seen um, data from our different data stores. So like, hey, if a lot of friends are watching the same video, that's something that should be in the cache to the right of it. If there's a trending topic, instead of like just requesting that like video ID and that information over and over again, hey, we know by now that just have it in the cache because that's going to reduce overall latency. Um, yeah, 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 yeah. And I just have like a general question. For like besides like the cache on the right, um, like you overall didn't want me to design that data store with all the video IDs to the right of that, right? That wasn't in the scope. Yeah. Okay. Okay. Yeah. Yeah. Yep. And wait, just let me end the video.